Hello student, welcome to our class. I hope you are good and you are doing good. Okay, so let's start our today's class 9 topic we will start today. Okay, so student, okay, so you have to observe the instrument like what you see this. Yes, this is a scale. Okay. Yes, very good. So, what you can see this? It's look like a pencil. Yes. Yes, very good. This is a pencil. Okay. So here you can see this is a whiteboard. Yes. Okay. So what we will do now? Now we will perform an activity. Okay. So here what we have to draw? So here we have to draw a triangle. Okay. First we will draw a triangle. Okay. By using the scale and marker. Okay. So here you can see that. Okay. Like here. Yes, I have drawn a triangle. Okay, so after drawing a triangle, what we have to do? So here we have to, we have to name the triangle like A, B, and C. Okay, so very good. So after that, after naming the triangle, after that we have to locate a midpoint F between this triangle. Okay, between this triangle we will locate a midpoint and name as a F. Okay, so here, yes, okay, so here I will take here a point and I will take as a F. Okay, as we can see that I have put here F. Okay, and name as F. So here I will set here one more line and we will cross this. Well, here we will make one line and we will see that this is intersecting line. Okay, so now here what you can see, like here what you can see, like triangle ABC and triangle EF. Okay, so here what we have to do, like we have to measure AE and EB, like AE and EB. Okay, so after that, now what we have to do, we have to find out that AE is equal to EB or not. AE is equal to EB or not. Okay, so here we will come to know to find the AE is equal to EB or not. Okay, so here, so now we will discuss about the conversion of midpoint theorem. Okay, so today's our topic will be the conversion of midpoint theorem. Okay, so this will be our topic today. Okay, so moving further, now you have to tell me what you have inferred from this activity, like as we have drawn this triangle, and what do you infer from this activity. Okay, so here now we will, like here we will see the theorem, like the line drawn through the midpoint one side of a triangle. Like we will see we have drawn this line midpoint of the triangle. Okay, so we have to check the triangle parallel to another side bisect the third side or not. Okay, so here this is the theorem. Okay, I will write over here the theorem. Like the theorem will be the line drawn through the midpoint of one side of a triangle parallel to another side bisect parallel to another side bisects the third side. Okay, so this is the theorem we have to do. Okay, so here coming to next, so here what we have to do, like we have to see that if f is the midpoint of the side AC, like f is the midpoint of AC. Here we can see this by coming this line, we can see this is f is the midpoint of this A and C. Okay, so here and EF like EF. Okay, so here we can see that E will be the midpoint of AB. Like here we can see. So here I will write like, we can see that F is the midpoint of AC, and here we can see that E is the midpoint of AB. So here we can see that EF and BC, like EF and BC is what it's look like. EF BC, what EF and BC is equal to like this. Okay, so here what's happening, like here it's becoming a triangle, and what this triangle is known as like conversion of midpoint. Okay, so here I have question for you, like a line which is bisecting two sides of a triangle which bisect the third side, is it true or false? You have to tell me the answer for this. A line which is bisecting two sides of a triangle will bisect the third side. So here we can see that a line which is bisecting two sides of a triangle will bisect the third side. The statement is false because it will not bisect the third line. Okay, third side. Okay, so moving further. Yes, so moving further here, student, what we have to do, you have to read a theorem. Okay, so here I will write that the theorem in whiteboard. Okay, so like the line drawn through the midpoint of one side of a triangle parallel to another side bisect the third side. What we have to do here, we have to bisect the third side. Okay, so here, student, I will write the theorem and what we have to do. Okay, so here the theorem is the line drawn through the midpoint of one side of triangle parallel to another side like bisect the third side. Okay, yes student. Now what we have to do here, so here we have to prove the theorem. Okay, so for proving this theorem, first what we need to prove here, like first we need to draw a triangle, like okay, like this, and we have to name this triangle as A, B and C, and here the bisecting like E and F. Okay, so I hope everyone is clear. So now here tell me what we need to prove here, like what we have need to prove here. So here we have to like prove EB is equal to like EB is equal to AE. Okay, so here we have to prove EB is equal to AE. Okay, so now you have what is the information like what is the information that we can take as given in this. Okay, so what we will take here, like given is f is the midpoint of the side AC. So here we can see that f is the midpoint of AC, like given is this. Okay, f is the midpoint of AC. Okay, so and EF is equal to BC. This EF and like this. Okay, BC. Okay, so here now you have to tell me how can we prove this. Okay, so here let's start the proof of this theorem. Okay, so here like we have to prove what, EF. Here we can see that EF parallel to BC. Okay, so let's prove this theorem. Okay, for that what we have to do, like we can see that the given is E, like we can see the given is like here E and F are midpoint of AB and AC respectively. Okay, so we have to prove this theorem, like. Okay, so coming to proof, so first what we have to draw a line CG parallel to AB. Okay, here we will draw a line like this. Okay, we can see. Okay, so we will name as a D and C, and this will be the G. Okay, so for proof we have we are told to draw a line. We have drawn CG. Okay, parallel to AB and extend EF Okay, up to D and intersection at CG, like intersection as CG. Okay, so next here we can see that in triangle AEF and triangle CDF we can see that it will be like triangle EAF is equal to triangle DCF. Okay, so here we can see triangle EAF is equal to triangle DCF. Okay, so here we can see same as like AEF and CDF. Okay, so this will be the alternate interior angle. What we will say as alternate interior angle. Okay, so here given like AF is equal to FC. So here AF is equal to FC is given. Okay, so this is given. So what we have to do, we have to draw vertically opposite angle, like triangle AFE is equal to triangle CFD. Like this is a vertically opposite angle. Opposite angles. Okay, like that we can see that. So here triangle AEF is not equal to triangle CDF. Okay, so like what is this angle side angle rule? What will be this angle side angle rule? Okay, so we are following the angle side angle rule. Okay, so after that we can see that AE is equal to DC. So here we can see that AE is equal to this DC. Okay, so for that what we will do, so okay, so I will write here. Okay, so AE is equal to DC, like this will be the CT form. Okay, So after that we can see that since in quadrilateral ED, like ED, B and C, okay, so what here we can see that EBCD, like EB is parallel to DC and ED is parallel to BC. We can say that EBCD is a parallelogram. Okay, so what we can see that EBCD is like a parallelogram. Here we can see that since in quadrilateral EBCD is like EB is parallel to DC, okay, EB is parallel to DC and ED is parallel to BC. ED is parallel to BC. So we can say that EBCD is parallelogram. We can say that EBCD is a parallelogram. So here we can see that this E, B, C, this D. What will be this? This will be a parallelogram. Okay. So I hope everyone is clear. So here we can see that EB is equal to DC. So here we can see that EB is equal to DC. Okay. So what we have to do here, here we can see that we can say that as a like EB is equal to AE is, okay. So this will be the proof of our theorem. So here the theorem is proved. So it will be like EB is equal to EC. So this is the form 1. Okay. So here I have one question for you, like which statement is true, you have to tell me. Okay, I will read the statement, like the line drawn through the midpoint of one side of a triangle perpendicular to another side bisect the third side. Or the second one is that the line drawn through the midpoint of one side of a triangle parallel to another side bisect the third side. Okay, so here is an option for you, like one is correct or two is option 2 is correct, or 1 and 2 both are correct, or none of them. So okay, you have to tell me your answer. Okay, we can see that the both theorem are like both statement are true. Okay, so the C option will be the right answer. Okay, so okay, very good. So again I have one question for you and you have to read the question. I will write here. Okay, I will write the question here and you have to read the question. Okay, and we have to see that what we have to do in that question. Okay, okay student, so here it is question. Please you read Ramesh this question. Okay, so you read this question, what is the question given over here. Okay, so yes, very good. So here we can see that L, M and N are three parallel lines intersect by transversal P and Q such that L, M and N cut off equal intercept AB and BC on P. Okay, so we can see that we have to show that L, M and N cut off equal intersect D, E and E, F on Q also. Okay, so I will draw that the intersecting line, or okay, so here first I will what do, first I will make a one triangle. Oh, wait a minute. So here I think whiteboard is visible to everyone. So first I will make like one triangle. Okay, so after that here we will see that the intersecting lines. So here we can see the intersecting image. Okay, so here, so very good. So now you have to you have to see the figure carefully and tell that what we need to prove here. Okay, so here what we need to prove after looking at this figure. Okay, so you have to tell me. Okay, so here we have to prove triangle DAF. To prove triangle DAF, okay, and triangle FED. FED. And after that we have to prove triangle BDE. And after that we have to prove triangle EFC. And we can see that this triangle are congruent to each other. We can see that this triangle are congruent to each other. Okay, so I hope everyone is clear. Okay, so here now you have to tell me what is the given in this question. Okay, so we can see that the given is DEF are midpoint of side AB, BC and AC. So here what we have given there, like given is that DEF, okay, are midpoint of side AB, BC, side AB, BC and AC, okay, respectively, and AC respectively. Okay, so I hope everyone is clear. Now you have to now you have idea to proceed what we have to prove in this question. Okay, so now tell me how we can prove this theorem. Okay, so for proving this theorem we will apply like we will see that DE is equal to EF. In this theorem we can see that DE is equal to EF. Okay, so here what we have to prove, we have to prove DE is equal to EF. Okay, so here what is given over here. So in this theorem we can see that the given is AB is equal to BC, like LMN. Okay, so we will prove this theorem. For that we can see that the trapezium, what this is trapezium. Okay, so trapezium A, okay, AC FD. Okay, so ACFD is a trapezium. Okay, so we can see that ACFD is divided into two triangles. Here we can see that they are divided into two triangles. Okay, so namely as triangle ACF and triangle AFD. Okay, so I will write over here. For I will write this theorem first, then after that I will write here. Okay, so here we can see that the ACFD is divided into two triangles. ACFD is divided into two triangles. Okay, so for that we can see that the first triangle is triangle ACF and the second one is the triangle AFD. Okay, here we can see that now here we can see that what will the here we can see that now in triangle AFD we can apply the same argument as G is the midpoint of AG. So AG and GE is parallel to AD. Okay, so after that, and so by the theorem we can see that DE is equal to EF. DE is equal to EF. So here we can see that the theorem is proved. So hence proved. Okay, so this will be the proof of this theorem. Okay, so after coming to Next, I have one question for you. Like the line drawn through the midpoint of one side of a triangle parallel to another side, dash the third side. What will be the answer here? So the answer will be the bisect the third side. Okay. So I hope everyone is clear. Okay. So let's move further. Okay. So here let's recall our today's class what we have learned. So we have discussed about one theorem and we proved that theorem and solve one question based on that theorem. Okay. So what is theorem? Everyone know. Okay, so I have homework for you. Like trying like ABCD is a trapezium in which AB is parallel to DC and BD is diagonal and E is the midpoint of AD. A line is drawn through the E parallel to AB intersecting BC at F, as like this figure will be in the homework. Okay, so we have to show that F is the midpoint of BC or not. Okay, so after that I have one activity for this, like draw 5 different triangle in which draw a line from midpoint of one side parallel to another side, stop at the intersection of third side. Now find out whether third side of a drawn triangle is bisected by that line or not. Okay, so I hope everyone have write down the homework and they will do homework. Okay, so let's stop our class today. This is this is only for today's class. Okay, so we will meet in next class. So thank you everyone. Okay.